Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. We are going to see the projections of straight lines when it is inclined to one plane. If you want to learn more about drawing and other subjects, other interesting subjects, please do subscribe this channel. If you like this lecture, please hit the like button. That will keep me motivated to do many such videos in the future. Now let's see how the line is when it is inclined to one plane. So here, if you observe this line, this is parallel to the vertical plane, and here making an angle with the HP. This is some angle. So let us see. Suppose a line 100 mm long parallel to VP and is making 30 degrees angle with HP. So this is parallel to, this is the line parallel to the vertical plane. That means both ends are at the same distance in front of VP and is making 30 degrees angle with HP. If you draw a horizontal line here, and this is making 30 degrees angle with the horizontal plane. Its one end is 40 mm above HP. This one end is 40 mm above the horizontal plane and 30 mm in front of VP. So 30 mm in front of VP. So this is the line. So here, if you observe, this point is 40 mm above horizontal plane and the entire line is 30 mm in front of VP. This distance is 30 mm. Now, draw the projections like this, and when it is seen in the front view, its projection is obtained here on the vertical plane. And because this line is parallel to VP in the front view, we get the true length of this line. And that is at theta, that is 30 degrees angle with the horizontal plane. And when it is seen from the top, the projection of this point A, B and A are obtained here. And because it is parallel to VP, it is the top view is parallel to the reference line. And here, because it is making an angle with the HP, the length is, the projection on the top view or the horizontal plane is less than its true length. So when a line is parallel to the VP, the projection onto the vertical plane is true length. Because here when it is making an angle with some plane, say in this case it is making angle with the HP, the projection onto the horizontal plane is less than its actual length or true length. So here let us see how to represent these projections. We draw a line here at a 40 degrees angle, 40 mm, right? 40 mm. So one end is 40 mm above HP. So we have marked the distance 40 mm here, 40 mm above the reference line, and 30 mm in front of VP. So at a 30 degrees angle to we call this point as some one end, right? This I call it as A dash. And from here, we draw a line at 30 degrees angle because this 30 degrees angle is seen in the front view. So we have drawn a line at 30 degrees angle. And in the front view, we see the true length of the line that is 100 mm long. This A dash, B dash is the 100 mm line. And the point B dash is marked here. From here, drop a projector onto the reference line and extend these projectors from A dash and B dash. So the top view is parallel because the line is parallel to VP. The top view is parallel to the reference line, right? Parallel to the reference line and is at a distance of 30 mm from VP. So at a distance of 30 mm from the reference line, we draw a line here at 30 degrees, 30 mm distance. So this is the top view of the line AB. So this is A and B, AB, the top view. So now, the front view is the true length of the line. Top view is less than its true length because it's making angle with the HP. These are the projections. Now, suppose we take another line, 100 mm long, parallel to HP and making 45 degrees angle to VP. So the line is like this. It's parallel to HP means both the ends A and B are at the same distance above horizontal plane. and it's making 45 degrees angle with, if you draw a line here, parallel to this VP, to this line, it is making 45 degrees angle. So it is like this. So the line is 60 mm above HP and its one end is 30 mm in front of VP. Draw its projections. So if you see this is 60 mm above HP. This is 60 mm above the horizontal plane. And this is the top view of the line. In the top view, we see the true length of the line because it is parallel to HP. So this is, we call it as the top view, true length, and it is marked as AB, right? And when you see it in the front view, we cannot see the actual length in the front view because this line is making an angle with VP. We cannot see the true length of the line in the front view. So it is the front view A dash, B dash. So less than, it's a true length. Now draw projectors onto the reference lines and we get the projections like this. Now we represent here by taking a reference line and the point 60 mm above HP and one end is 30 mm in front of VP. Mark a point here at a distance of 30 mm, right? 30 mm from the reference line. We call it as A. And the line is making 45 degrees angle with the VP. So from A, you draw a line here at a 45 degrees angle. On this, we mark the actual length, let's say 100 mm long. So 100 mm distance is marked here from A. This is B, right? So AB is 100 mm and highlight this and show the dimension. Now from B, you draw a projector onto the reference line. Okay. Now, the front view is 60 mm above HP. The line is 60 mm above HP. So in the front view, from here, it is at a distance of 60 mm. Draw a line parallel to the reference line and the front view lies here on this line. Draw projectors from A and B like this. Projectors. These points, intersection points will be the A dash and B dash. Highlight this A dash, B dash. This is the front view of the line. So here, when because the line is parallel to HP, the top view, you are getting the true length. In the front view, because it is making some angle with VP, in the front view, we cannot see the true length of the line. So this is the way of getting the projections of the line. Now, when it is making angle with the VP, let's take another problem. Straight line 100 mm long is in VP, right? It is in the vertical plane and is making an angle with HP. So let's we have to just represent the data as it is. You need not have the planes and all. Just let us represent the data. The true length is given as 100 mm long. It is in VP, okay? The line is in VP and is making an angle with the HP. So its one end is 20 mm above HP. So we mark a point here at a height of 20 mm above the horizontal plane, right? We take one point here somewhere. Okay. We call it as one end A. So we call it as A dash. Okay. So this is A dash. Its top view lies in the reference line because the line is in VP. The line is in VP. So its top view lies in the reference line. This is A. Now, it is appearing as 60 mm long in the top view. So its top view is, the line is in VP and its top view is 60 mm. So the top view, the line is appearing as in the top view and this distance is AB. The top view AB is 60 mm. Draw a line of 60 mm long and this point will be B here. Now, we got the top view of the line. Now, draw its projections and find the inclination with HP. The angle with HP is not given. We have to find it. So, how? This is something like this. It is making some angle with HP. To get it, we know the true length of the line. So, we draw the projectors from the B. We draw a projector here and B dash must be lying somewhere here. And we know the true length of the line. In the front view, we can see the true length of the line. Okay. So from A dash with 100 mm radius, draw an arc which is intersecting this projector. This is B dash. So join A dash, B dash. That is the front view of the line. So this is the way of getting the inclination with HP. Measure this angle and that will be the angle with the horizontal plane. Okay. Suppose you are given a straight line AB parallel to VP and is making an angle with the HP. It's making some angle with the HP. Parallel to VP. It is 15 mm in front of VP. Okay, let's represent the data first. So here you are actually asked to get the true length of the line. It is not given. We are asked to get the true length of the line and the inclination with the horizontal plane, both. So let us find. It is 15 mm in front of VP. So the reference line, 20 mm and 40 mm above HP. So here its end A is 20 mm and B is 40 mm above HP. At a 20 mm height, we draw a line. Somewhere here, at this height, the point A, front view must be lying. That is A dash. And I have taken some point here, okay, on this line somewhere. This is at 20 mm above HP. And at a height of, and of course, here let's represent the in front of VP. That is, the top view is 15 mm from the reference line. Draw a projector and its top view is marked at a distance of 15 mm here, and this is A here. Okay. Now, its top view is measuring 50 mm. The top view length is 50 mm, and also we know that AB is parallel to VP. That means in the top view, the line is parallel to the reference line. The projection is parallel to the reference line. So at a high distance of 50 mm, we have drawn a projector here. And we know the point A. A is 15 mm in front of means B is also 15 mm in front of VP, that is parallel to the reference line. So draw a line parallel to reference line, which is of 50 mm long. So this is AB, the top view of the line. From B, we draw a projector here. Okay. B dash will be lying somewhere here on this projector. And how to know? B is 40 mm above HP. We are given that the position of the point B is from the reference line. It is at a height of 40 mm. Somewhere, if you draw a line here at a height of 40 mm, on this line, the point B must be lying. So it must be lying on this projector as well as at this height. That means this intersection point itself will be B dash. So join A dash and B dash. That will be the true length of the line. How do we say that? Because the line is parallel to VP, that is seen in the front view. Whatever you see in the front view is the true length of the line. So when the line is parallel to the vertical plane in the front view, we see the true length and also the angle with the horizontal plane. This is the angle. So we measure the angle here. These two angles you can measure, and that's how to get the or find the true length and angle. Okay. Now, let's take another example. A straight line AB parallel to HP and 30 mm above HP. Okay. Here, actually, you are asked to get the true length of the line. So, AB is parallel to HP. The true length is not given. Parallel to HP and 30 mm, 35 mm above HP. And is making 60 degrees angle with VP. We are given the angle with VP. Okay. So, let's represent the data as it is given. That parallel to HP means in the front view, the line is parallel, its projection is parallel to the reference line. Okay. And 35 mm above HP. At a height of 35 mm, we have taken this. So this is A dash, the front view. So its top view must be lying on the same projector. So draw a projector from A dash, you get the top view. So we got one point, one end of the line. So its end is A is in VP. That's why you have taken on the top view is on the reference line. Its front view is measuring 50 mm. Front view is parallel to the reference line. We know that because it is parallel to HP. And its front view length is 50 mm. That is A dash, B dash. This length is 50 mm. So at a distance of 50 mm, you draw a line and that will be the front view of the line. Also, we know that the line is making 60 degrees angle with VP. So from A, draw a line here at a 60 degrees angle to the reference line, right? And the top view is lying somewhere here. It's like this. Its top view is this. But how much? Way to know? That is obtained here with the help of the front view. So let's mark this front view 50 mm distance. So this will be the B dash. Okay. So this is the B dash. From B dash, A dash, B dash is the front view, which is of 50 mm long. Now from B dash, draw a projector onto the reference line and extend this further. The top view of B must be lying on this projector and also on this line, 60 degrees line. So the intersection point itself will be B, the top view. So what is AB? The true length of the line, because the line is parallel to HP. When it is parallel to HP, in the top view, we get the true length of the line, and also this is the actual angle with the vertical plane. So we are able to get the true length of the line like this. You measure this length and that is the true length. Okay. So hope you had understood this topic very well. And if you have any queries or suggestions, please do comment and then do subscribe the channel and get alerts. Let us see the continuation of these lines in the next video. Thank you.